Alright, this video we're going to be talking about exponential functions. What they are, they're functions whose equations contain a variable and the exponent. The general form of it would be f of x equals b to the x, and you see that the variable x is located in the exponent. And you could also write this as y equals b to the x power. Now there's a couple restrictions in terms of what b can be. The first thing would be that b has to be positive, and it also can't equal 1. The reason why it can't equal 1 is because if b was 1, it would look like this, where no matter what you plug in for x, or what x is, your output is always going to be the same. It's going to equal 1. In that case, it's not going to be an exponential function, it's going to be a straight line. If it was 0, you would have y equals 0 to the x power, where again, if you put 0 squared, 0 cubed, 0 to the 4th, you would get the same output every single time. So that's the reason why it can't be 1 and it can't be 0. The reason why it can't be negative is because if it was negative, for example, y equals negative 2 to the x, if b was negative, if our x value was something like 1/2 or 1/4 or 1/6, what would happen is the outputs would not be real. And the reason why is because negative 2, let's say x was 1/2, negative 2 to the 1/2 power is the same as the square root of negative 2, and that is imaginary. So it would not have a real output. So we can't have that. So it can't be 1, it can't be 0, and it can't be negative. So essentially, it has to be greater than 0 and it can't equal 1. Now, the x values can be anything. The x values just have to be real. So the domain, therefore, would be all real numbers. So the x values need to be real. In other words, not imaginary. Because of this, the domain for these exponential functions will always be negative infinity to positive infinity. In other words, all reals. Let's look at an example of an exponential function, a specific example. So let's say we had f of x equals 3 to the x power. What we can do in order to get some points would be to create just a quick xy table, where we can go from negative 2 up to 2. Now if I were to plug these values in there, if I were to substitute negative 2 for x, 3 to the negative 2 power is 1/9. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. And 3 squared is 9. Now you might not remember these two here, how to find the output. So I'll just to the side here. 3 to the negative 2 power is the same thing as 1 over 3 to the positive 2, which is 1/9. The reason why this is the case is because if you were to write this as a fraction, you can take this here, move it down on the fraction line, and that changes the sign of the exponent. and you'll be leaving a 1 in the numerator. So it'd be 1 over 3 to the positive 2, which is 1/9. Okay, so let's do a quick graph for this. Okay, so just go 5. We'll have to go up to 9. Let's go way up there. And then that should be good. Okay, so -2, 1/9 will be right there. -1, 1/3, 0, 1, 1, 3, and 2, 9, way up here. Okay, so the actual graph of this is going to look like this. Now you'll notice that the x-axis looks like it would be asymptotic, and in fact it is. The x-axis for this example is an asymptote. The outputs, no matter how far left you go, or how low you go on the x-axis, it will always contain a positive, or it will always result in a positive value. For example, 3 to the -100 power would end up being 1 over 3 to the 100 power. So it would be 1 over 3 to the 100th, which is an enormous number down here, and this would result in a number that is extremely close to 0, but it's still positive. It's still a positive value. So it's just above the x-axis. And then this over here, because it's exponential growth, it increases at a really, really rapid rate. So that would be an example of this graph. Another example that we could do might be where b is not greater than 1 but less than 1. So let's take a look at what that might look like. Let's say g of x equals 1/3 to the x power. So let's do an xy table. Let's plug in -2 to 2 again. Alright, so -2 being the power would be 1/3 to the -2, which is 1 over 1/3 to the +2, which is 1 over 1/9, which is just 9. 1/3 to the -1 would be 3 if you did it out. 1/3 to the 0 is 1. 1/3 to the 1 is 1/3. And 1/3 squared is 1/9. So the graph of this one is going to look just like the other one. But flipped over the y-axis. So -2, 9 be way up here, -1, 3, 0, 1, 1, 1/3, 2, 1/9. So we're going to have that as our graph. And if we look back at our other graph, you see that it looks almost identical, but it's just flipped over the y-axis. Okay, so there are specific questions that we could answer regarding this. few of the questions might be, for example, the domain of this. So the domain of this graph, and we already talked about this, x can be anything. So it would be from negative infinity to positive infinity. The range for this graph, if we look at it, the very lowest that it goes is just above 0. So it starts at 0 and it goes all the way up to positive infinity. That's the collection of outputs. If we were to answer the question of what is the horizontal asymptote, the horizontal asymptote for this would be the equation y equals 0, because it's approaching 0 but it will never hit it. I could ask whether it has an x-intercept and what it is. In this case, it doesn't hit the x-axis, so there's no x-intercepts. For the y-intercept, there is one. It's right over here. It's the value of y when x is 0, and we already found that out. It's 0, 1. And the last thing that we could talk about potentially is whether it's increasing or decreasing as x increases. So if we look at the graph, as we go from left to right, the graph is going down. So that means it's decreasing. Now the other things that we could be talking about would be something called transformations, and that's the next thing that we're going to be going over. Okay, so when we're talking about transformations, we're going to be talking about all the possible things that can happen to an exponential function. And what's good is looking at the equation with variables representing all of the things that can happen to it. So instead of just looking at f of x equals b to the x power, we're going to include a, h, and k, and they're going to represent all the different things that can occur to a graph, and then we'll look at a specific example. When it comes to the a value, if a is negative, if it's less than 0, there is going to be a reflection over the x-axis. It's going to be flipped right over the x-axis. Now, that could mean that a could be -2, it could be -1/2, it could be -3, it could be -1. If the value in front of the base is negative, it's a reflection over the x-axis. That's one thing that the a value will tell you. If a is positive and it's greater than 1, then there's going to be a vertical stretch. If a is in between 0 and 1, then there's going to be a vertical compression. It's going to look like it flattens out a bit. If it's a vertical stretch, it's not going to flatten out, it's going to look like it's literally vertically stretched. So it's going to be higher and almost skinnier in a sense. So a tells us 3 particular things. The h value will tell us other things. So if over here, if you see x plus a value, then there's going to be a horizontal translation to the left h units. So in other words, like if you were to see x plus 3 in the exponent, that would mean you're moving left 3 units. You sort of want to think the opposite of what you're looking at, because typically when we see a plus, we think of going to the right because of the number line. But in this case, and this also happens with parabolas in vertex form, when you see the x plus h, you want to think left. If you see x minus a value, then you're going to have a horizontal translation to the right h units. And what a translation is, it's just literally picking up the graph and moving it left or right, and as we'll see with the k value, up or down. That constitutes a translation. A translation is a type of transformation. It's a very specific type of transformation of a graph. Alright, now let's look at what k does. So for k, if you see a plus k at the very end, then there's a vertical translation up k units. So with the h value, we sort of thought opposite of what we saw. If it said x plus 1, that would be left 1 unit. If we saw x minus 7, we would think right 7 units. But with the k value, you actually, in a sense, listen to what your eyes and what the k is telling you, what you're seeing. You're actually obeying it. So if you see plus 3 at the very end over here, then that means you go up 3 units. You know, if you were to see a minus 5, it would be down 5 units. So if you have minus k at the very end, then that means there's a vertical translation down k units. So that's what k tells you. This is what a told you. This is what h tells you here. Alright, so let's sort of look at all of this and put this all together. Let's look at, we won't graph this, but we'll just take a look at all the things that are happening to it. Here's a very specific example. Let's say if we had f of x equals negative 1/2 raised to the x plus 2 power minus 3. And if I were to ask you, what are the transformations of this graph? If I were to say list all of the transformations, the first thing you should do is look at what's in front of the b value. My b value is 1/2. That's your base. So in a sense, in the back of your mind, you're asking yourself, what's happening to my run-of-the-mill 1/2 to the x power? What's happening to this base of 1/2 raised to the x? Something's happening to it. Well, the first thing that's happening to it is that you've got a negative 1 in front of the 1/2. So your lead term, your a value, is negative 1. That means that there's going to be a reflection over the x-axis. That's the first thing that you'll see here. Now, because the a value is -1, the 1 value is not going to stretch or compress it at all. The a value would have to be, the absolute value of the a value would have to be greater than 1 or in between 0 and 1 to actually have this affected. Now, I should have mentioned over here that we're really looking over here when we're talking about if a is greater than 1 or if it's in between 0 and 1, we're looking at the absolute value of it. Because if you see like -5 up here, then it wouldn't apply to any of this. But the -5, we're looking at the 5 value. We're kind of ignoring the negative. The 5 value tells you that there's going to be a vertical stretch. So I should have mentioned that we're looking at the absolute value of a. Okay, so that's the first thing that happens. So there's a reflection over the x-axis. The second thing that happens, since we're done with a now, is right over here. We have in the numerator our h value. We're looking at the exponent as x plus 2. That means there's going to be a horizontal translation left 2 units. Because we see the plus 2, we're thinking right 2. We can't think that way when we're talking about transformations. We think the opposite. And the very last thing that we look at is the k value right over here. The k value is -3. That means there's going to be a vertical translation down 3 units. Because we sort of obey what the k value tells us. So these 3 would represent the transformations that occur to this parent function. So we see that the negative flips it, left 2, down 3. That's essentially what's happening to the transformations. Now there is one other transformation that can happen, and that occurs when the exponent is negative, when the x value is negated. If that should happen, then there's a reflection over the y-axis. Just list this with everything else. Reflection over the y-axis if the exponent is negative. If the exponent, or the variable in the exponent, is negative. And we're talking about the variable in these cases because if it was just y equals 3 to the -5, well, that's not an exponential function. Because remember, an exponential function has to have a variable in the exponent. And if that variable is negated, then there's a reflection over the y-axis. Whereas if the a value is negative, that flips it over the x-axis. So if this is negative, it's a reflection over the x-axis. If the x value up here in the exponent is negative, there's a reflection over the y-axis. And I think that's it.